Hi dear, in this video we will study about the scientific notation, and before that let's see how scientific notation help us in solving math. So why we need scientific notation? Basically in science we deal with some very large numbers. For an example, 1 mole is equal to 602 and 0000, so many zeros are there, 21 zero actually. In same way, we also deal with some very small numbers. For an example, mass of an electron, which is equal to 0 decimal 0.0000031 and then 91 kilogram. So you can see how small is the weight of electron. And now if a question is asked to find out the total mass of 1 mole of electron, then think the complexity of the calculation, how difficult to calculate the mass of 1 mole. So basically we have to multiply mass of 1 electron, which is 0.310 and 91 kg, with 1 mole value, and then how we will manage all these zeros. So to at this point, scientific notation come at place and help us our math. So basically, scientific notation, also called scientific exponential or standard form or standard index form. This is a method or way to handle a very large or very small numbers, they which are written conventionally in decimal places. So there is one set of standard method for writing scientific notation, which is a very simple formula, that is a times 10 raised to the power of b. We read in this way, this formula, where a is a coefficient and it can be any real number, and b is an exponent that can be an integer. So let's take an example. If we want to convert 100 into scientific notation, we will write 1 times 10 raised to the power 2, and if we want to convert 9500, this will become 9.5 times 10 raised to the power of b, raised to the power of 3. In example number 2, if we want to convert 0.01, this will become 1 10 raised power of minus 2, and 0.0095 will become 9.5 into 10 raised power minus 3. So let's see how we can convert these values into scientific notation. Here we are taking two examples. In the example number 1, we are going to convert 1,500,000,000 into scientific notation, a times 10 to the raised power of b. So you can see there is a no decimal point. So let's add an arbitrarily 0 at the right place, right hand side, and then we will move this decimal plate one by one all the way just before 1. So let's move up to here, and we have to count how many places we move. So 1 2 3 4 5 6 7 8 9, we will move this decimal place up to 9th place, and then we can write the scientific value as a 1.5 times 10 to the raised power of 9, because this 9 is an exponential, and it comes that how many times, how many places we move, how many times or how many places we move this decimal place from right side to left. We have to move decimal place only up to first integer. I mean, we have to place this decimal just before first integer, not after this. So this is the rule of scientific notation. Let's see another example number 2, where we have to convert 0.0000623 into scientific notation. Here we will move our decimal from all the way left side to the right, and we will put this decimal just after first integer or first non-zero value. So let's move first, second, third, fourth and fifth. So we will move this decimal place up to 5 places, 5 times. Then we will write the value 6.23 times 10 raised power minus 5. So minus 5 because we move this decimal place 5th place from left side to right place side. So this is the way how will you convert normal decimal value into scientific notations. Here is one more thing important. If we are moving decimal place from right side to left side, for an example in 1, then exponent value increases, means this one small b, or here 9. In example 2, we move decimal place from left side to right side, therefore exponent value decreases. You can see minus 5 is much smaller value because we move decimal place from 5 times or 5th place from left side to right side. So this was the about the scientific notation. We will see some more examples: addition, subtraction, multiplication and division in another video, and I hope you will like this video. Thank you.